This is Algebra 2, Lesson 4-5, Quadratic Equations, with a review of radicals. We'll start with the review of radicals. The radical symbol indicates a square root. In general, the square root of x squared is the absolute value of x for all real numbers. We always say it's the absolute value of x because you're looking for the principal square root, which is always the positive square root, and we don't want to accidentally introduce the negative when it comes to variables. So let's remember the following properties. The multiplication property of square root says for any number in which a is greater than or equal to 0 and b is greater than or equal to 0. If you multiply the square root of ab, that's the same thing as multiplying the square root of a times the square root of b. The division property says that if I have the square root of ab, it's the same thing as having the square root of a divided by the square root of b. We did some simplification in geometry when we had to simplify square roots to be able to work with special right triangles. So we're going to do the same thing here. It's the same process. If I'm going to simplify, I'm going to break it down to prime factors and then pair up all my prime factors into pairs and then take out what I can. So if I have the square root of 18, all I need to do is break this up. So if I have 18, which breaks down to 2 times 9, and 9 breaks down to 3 times 3. Remember, in order to take something out of the square root, you have to have groups of 2 because it's a square root. So I pair up my numbers so the 3 can come out, the 2 has to stay underneath, so the square root of 18 becomes 3 square roots of 2. The negative square root of 32, that's going to be 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. If I pair up my 2's, I can take out 2 pairs of 2's, which get multiplied together, and I'm left with 1 2 that gets left underneath. 2 times 2 is 4, square roots of 2, but remember this was negative, so it should be negative 4 square roots of 2. The negative square root of 7/13, that's the same thing as saying negative square root of 7 over the square root of 13. If you remember earlier from earlier things that we've learned in both algebra and geometry, you cannot leave a square root in the denominator. It's not a rational number, it's an irrational number. To make it a rational number, we must rationalize the denominator. So I'm going to rationalize the denominator by multiplying by the square root of 13 over the square root of 13, which is just a fancy way of saying the number 1. So all I'm really doing is multiplying by a 1, which doesn't change my problem. It gives me a very similar problem. So negative square root of 7 times the square root of 13 becomes the negative square root of 91. And the square root of 13 times the square root of 13 is the square root of 169, which is just 13. So you get negative square root of 91 over 13. If I take 2 square roots of 27 and I want to square that, that literally means 2 square roots of 27 times 2 square roots of 27. So outside times outside, 2 times 2 is 4. Inside times inside, the square root of 27 times the square root of 27 is the square root of 27 squared. Okay. Which means I end up with 4 times 27, because the square root of 27 squared, the square gets rid of the square root, and 4 times 27 is 108. If I take the square root of x squared, y squared, the same thing as saying x times y, you pair them up, and you end up with x, y, but we must put this in an absolute value symbol because it's a variable, and we're not sure if the variable is positive or negative, and we don't want to accidentally introduce a negative because you can't take the square root of a negative number yet. You will be able to do so before the end of this chapter. So if you take an odd number of variables out of an even numbered root, you must have an absolute value symbol so as not to accidentally introduce a negative. That's very critical to know. Number 6, if I have the negative square root of 7x to the third over 5x. Before I even think about doing anything with this, I'm going to simplify it because I can cancel one of the x's to the bottom for one of the x's to the top. So now I have the negative square root of 7x squared over 5. So that's negative square root of 7x squared over the square root of 5. Okay? I can take out the x out of the 7x squared, so I have negative absolute value of x, square roots of 7, all over the square root of 5. Now I need to rationalize the denominator for this. So I will rationalize the denominator by multiplying both the numerator and the denominator by a fancy form of the number 1, otherwise known as the square root of 5 over the square root of 5. And I will get negative square root of, actually absolute value of x, square roots of 35, all over 5. And you cannot simplify the 5 with the 35 because the 5 is outside the absolute value, so, or to be outside the square root, and the 35 is inside the square root, the 5 is outside the square root. In order to simplify them, they either both have to be underneath the square root, or they both have to be outside of the square root. So that's just reviewing radicals, and the reason I did that is because when we get to quadratic equations, we have to be able to deal with radical numbers. We have to be able to deal with square roots. One of the main reasons we use work with quadratic equations is because we want to find the zeros of a function. The zeros of the function is when the graph of a function f of x intersects the x-axis. For example, if I had a graph that looked like this, there's my x and y axis, and let's say my graph looks like this, the two places where I have the two green dots here are the zeros of the function because that's where they intersect with the x-axis. You can solve some quadratic equations in standard form by factoring the quadratic expression and then using what we call the zero product property. The zero product property basically says if a times b equals 0, then either a equals 0, b equals 0, or they both equal 0. Right? For example, if I have x plus 3 times x minus 7 equals 0, then x plus 3 must equal 0, or x minus 7 must equal 0. So to solve these equations, the first thing I can do here is if I have x squared plus 7x equals 18, first thing I should do is set this equal to 0. So I'm going to move my 18 over by subtracting it off of both sides. So I have x squared plus 7x minus 18 equals 0. Now I'm going to factor this. I need two numbers that multiply together to get negative 18 and add together to get positive 7. So I'm looking at negative 9 and positive 2. So x minus 9 times x plus 2 equals 0. Now I need to solve both of these for 0. So x minus 9 equals 0 and x plus 2 equals 0. So if I solve this, I will add 9 to both sides here. X equals 9. Here I'll subtract 2 from both sides. X equals 2. So the zeros of this function, or the solution to this equation, is x equals 9 or 2. Number 2, 2x squared plus 4x equals 6. Again, I need to move the 6 over, so I'm going to do 2x squared plus 4x minus 6 equals 0. And I'm moving into the other problems on the board, so I'll just move those down. Now I need to look at this and I can see right away I can take out a 2. My greatest common factor is a 2, so I'm going to take that out, and I'm left with x squared plus 2x minus 3 equals 0. So now I'm going to leave the 2 alone for now. I'm just going to deal with what's in the parentheses. I need the product of two numbers whose product is negative 3 and the sum is 2. That's going to be positive 3 and negative 1, so x plus 3 times x minus 1 equals 0. I'm going to put that 2 back now. So now I've factored that entire equation. Now to set this equal to 0. 2 does not equal 0. There's no variable there. 2 does not equal 0, so that's just, you ignore it because there's no variable associated with the 2. But the x plus 3 and the x minus 1, x plus 3 equals 0, x minus 1 equals 0. So subtract the 3. So x equals negative 3, add the 1, or x equals positive 1. Okay, problem number 3 here, which I'm just going to transfer down here so that I can see it a little bit better. Problem number 3 is 16x squared equals 8x. I'm going to move the 8x over by subtracting it from both sides. So I get 16x squared minus 8x equals 0. Greatest common factor? 8x. So I'm going to take it out. that's going to leave me with 2x minus 1 equals 0. Now, the last problem we had 2 on the outside, and I said 2 could not equal 0 because there was no variable. Here I have an 8x on the outside. Since there's the variable x, I can set that equal to 0. So 8x equals 0, or 2x minus 1 equals 0. And I can solve both of these problems by dividing by 8, x equals 0. Here I will add 1, and I get 2x equals 1. Then I divide by 2, x equals 1/2. So the solution to this equation, or the zeros of this function, are 0 and 1/2. And the last problem up here, which was 3x squared minus 20x minus 7. So I'm going to write that over here again so that I can see it really clear. Number 4 was 3x squared minus 20x minus 7 equals 0. So I need product of two numbers, product of negative 21, sum of product of negative 21, sum of negative 20. So I'm thinking negative 21 and 1, and I'm going to factor this by grouping. So 3x squared minus 21x plus x minus 7. First 2, last 2. I can take out a 3x out of the first one, and I'm left with x minus 7. Out of the second one, I can take a 1, and I'm left with x minus 7. So I get 3x plus 1, and x minus 7 equals 0. So 3x plus 1 equals 0, x minus 7 equals 0. So I'll subtract my 1. 3x equals negative 1, divided by 3. X equals negative 1/3. Here, add 7, so x equals 7. So when they factor, it works quite nicely. Another way you can solve is you can use the table feature on your calculator. To use the table feature on your calculator, you need to put your equation into your calculator. And it doesn't matter if you're going to use your Inspire or you're going to use your 84, you're still going to do the same basic thing. You're going to put the equation in as if you were going to graph it. So you have to put it in y equals form. So get your y equals graph. So on my 84, I would just put in 4x squared minus 14x plus 7. Oh, well, the first thing we got to do is set it equal. We got to put it in a form we can use. So I'm going to add x and subtract 4. And by doing that, you get 4x squared minus 13x plus 3 equals 0. So we have to make sure it's in standard form first. Now that it's in standard form, I can plug it into both of my calculators, and I'm going to put it into both of them because you essentially do the same thing. So I'm going to enter it into my calculators. I'm going to put in 4x squared plus minus 13x minus 13x plus 3. And then I'll put it in the second calculator. 4x squared minus 13x plus 3. Graph them both. Even if they're graphed, you know, graphing is one thing. You can kind of look at the graph to get an idea of where your zeros should be. And if I look at my graph, it appears that I have a 0 a little bit past 0, but less than 1. So we're looking at less than a half. And then it looks like another one that might be at maybe 3. So when I go to my table, on the TI-84, you're just going to go to second graph, because that's the table. And you want to make sure you set your table up, because we're obviously getting a number that is less than 1, but greater than 0, so it's a decimal. And I'm not sure what decimal, it's a decimal, it's a fraction. So I need to make sure that I have a table set. So on the 84, go to second window, and that's your table setup. And I'm going to start at 0, because I know it's got to be less than, greater than 0. And then there's a little triangle table, that's delta table. We're going to go by point 1. So put that in your 84. On my TI Inspire, remember Control T gets you your table. So what I'm going to do here is it brings up my table. Now I need to hit menu to change my table. It says actions and table, go down to table. And it's going to ask you to edit table settings. So we're going to go to the table settings. I want my table to start at 0, but I want my table step to be 0.1. And then I'm going to hit OK. And then you'll notice that it's going to give you fractions or decimals, however you just have your calculator set up. Right? So if I continue to scroll down here, right, I might be looking at, right, and if I do the second table on the TI, we're looking for where y equals 0. Right? So we knew that that was, and we're getting, I'm looking at this going, I'm not getting something that's very good here. So maybe instead of going by tenths, okay, I should go by something a little bit smaller than, well, maybe a little bigger than tenths. Okay, so I'm looking at my table going, I'm not getting things here. So I'm going to hit my second table again. And I'm going to do my table setup again. Maybe my, I'm going to go by fourths. 0.25. Oh, there we go. I got it. So if I go to menu and change my table on my Inspire, edit table settings. Now I'm changing my table. I'm going to go by 0.25. And I did that because I'm noticing I didn't get a 0. Okay, if I enter that, I am looking to try to find where y equals 0. So I need to find where y equals 0. And so if you go down there, you should be able to see that at 1/4, y is 0. Okay, and then if we continue to scroll down, we need to find the second 0. We thought that was about 3, so we look at the table, and yes it is, it's a 3. So if we look at our calculator, we found that our x was at 0 at 1/4 and 3. And you have to look at the graph first. From the graph, you try to get an estimate of what it is, then bring up the table. And sometimes you have to change the settings on your table so you can pull it up a little bit easier, so you can find where your 0 is. Let's do one more of these. So 10x squared plus 2x minus 46 equals x minus 4. So we're going to subtract x and add 4. So we will get 10x squared plus x minus 42 equals 0. Again, I will put those on my calculator. So if I put those in my calculator, 10x squared, so it's fun to try to put them in 2 calculators at the same time, plus x minus 42. And if you're on the 84, make sure you get a new screen, a new graph. You want to delete your old graph, otherwise this might confuse you. Okay, so if I graph these, it appears that they're going through what looks like -2 and +2. So it looks like I might be able to pull up my table and go by ones. So I'm going to hit Control T again for the Inspire and just go to second graph for the 84. And what we said, what, -2? Looks like -2 is at a 0. Nope, it's not -2. Okay, a 2 0 is 1, that's for sure. So it's got to be less than -2. Maybe it's not falling right on -2. Maybe it's a little bit over -2, so maybe we should try pulling something by tenths again. So we know that one of the zeros happens to be, okay, if we scroll down, we know that at +2 it's a 0, so we know that x is equal to 2. We know that much from our table. We need to find our other 0. So if I pull up my table again, if I hit the menu and go to the table actions, or if I go to second table set for the other one, And instead of going by by ones, I'm going to go by 0.1. Alright, so if I go, oh, there we go. Negative 21 tenths or negative 2 and 1/10, it's 0. So negative 21 tenths, negative 2.1 is my other 0. The table feature is not the easiest way to find 0. There are other ways to find zeros using your calculator, and I will show you those a bit later. You do need to know how to use your table though. Alright, so the other thing we can do is we can graph. Okay? It says to solve a quadratic equation by graphing. You're going to rewrite it in standard form, and then now we're going to use a different function on our calculator. Okay, so again, we're going to put it in the calculator. We're going to put the equation in. The first one's already written in standard form. So we're just going to put in a new equation. So we're going to put it in as x squared plus 2x minus 24. So x squared plus 2x minus 24. And we can graph that. And keep the graph up because you're going to want that graph. That's going to be really, really important. X squared plus 2x minus 24. So if I graph them both on either calculator, I have a nice little graph, and it kind of looks a little bit, I'll kind of trace it over here. Here's your x-axis, here's your y-axis, and you have a graph. It looks like it's going like this. It's going off my screen like that. Okay? So I have a 0 here and a 0 here somewhere. And I need to figure out where those zeros are. I don't want to have to use the table feature on my calculator, so I'm going to actually use the 0 feature on my calculator. I'll walk you through it for each calculator. For the 84, you're going to hit second and trace because you're going to calculate. You'll get to the calculate screen, it'll say value 0, minimum, maximum. Go to the 0, hit enter. Then it's going to say left bound at the bottom of your calculator with a little question mark and it says x equals 0. You need to use your up and down arrow keys until you see a little cursor come on your screen. And I need to get way over to the left. Actually, it's the left and right arrow key. I need to get way over to the left. Oh, there's my little cursor. It's a black circle with a little, looks like a little X, and it blinks. You need to have that above your x-axis for your first one. It says left bound. I put mine at negative 6.17 or so, and I'm going to hit enter. Then it's going to go right down. Hit your right cursor until it's below the x-axis on the left side of your y-axis. Hit enter, and it's going to say guess, and you just, this is what it's guessing. Hit enter again, and you're going to get 0 equals x equals negative 6, y equals 0. So your x is at negative 6, so negative 6 is going to be zeros. To get the second one, you're going to hit second trace again. You're going to go back to 0, hit 0 again. Now you're going to hit your right arrow key until you are below the x-axis as the graph is coming up the other side for your left bound. And it's going to take a while. There you go. And as long as you're on the right-hand side of the y-axis and below the x-axis, you can hit enter. And then scroll until you are on the right-hand side of the y-axis, but above the x-axis, hit enter again. And it's going to ask you to guess, and it's going to give you your other zeros at 4. For the inspire, you're going to do something very similar. Okay? You're going to go to hang on a second, I lost my breath a second. Okay, so back on my graph. So to get to your calculate, you're going to hit menu, okay? And you're going to go down to 6 where it says analyze graph. You're going to go to the right, and it's going to, the first thing that pops up is 0. Hit enter. And it's going to do basically the same thing, except for now you've got a little finger that points and it looks like a dotted line that goes vertical. Take that dotted line to the left side of your parabola. So you're going to have a dotted line that looks like this. Move that dotted line so it's on this side of this dot. And hit enter. Okay? Then you're going to move that dotted line using your cursor so it's on the right-hand side. So you're going to have a dotted line on both sides of your cursor, and this is going to be shaded in right here. As soon as that, where the graph crosses the x-axis is between those, hit enter, and it's going to give you what the 0 is. It shows you right there. It'll put a black dot on the 0 and it'll say -6, 0. Do that again on the right side, so you're going to hit menu, analyze graph again. You're going to find the 0 again, and you're going to move your little vertical line so it's now you're going to have a vertical line that's going to be here. You want to have one there and one there. It's going to be shaded in between here. So we're going to put enter, and then I'm going to move it over to the other side, and I'm going to hit enter again, and it's going to tell me my 0 is at 4, 0. So -6, +4. And again, I'll show you these in class as well, but in case you missed class, you at least have an idea of what we're working with. Second graph here, 5x squared, we're going to put it in standard form, 5x squared minus 18x minus 8 equals 0. I'm only going to do this one on the Inspire because you should be able to figure it out by now. So I'm going to put a new graph in here. So I'm going to put my graph in, and it's 5x squared minus 18x minus 8. Graph that. I can see, then I'm going to hit menu, analyze graph, find my zeros, move my little cursor thing so that it's on the left side of the leftmost 0, and we'll find it on the right side, and it tells me my 0 is at -0.4. So x equals -0.4. To find my right-hand 0, I'm going to do the same thing. I'm going to analyze my graph, hit menu, go down to analyze graph, I want 0. I'm going to move my little vertical line closer to where my point is, and it tells me it's at 4, 0. So it crosses is at -0.4 and +4. The graphing feature, I find the intercept with the 0 is much, much easier to use than the table feature, but it is kind of important to be able to use both. All right, last question we're going to work with here. A word problem. The function f of x equals -0.002x squared plus 0.77x models the path of a baseball where f of x is given as the height of the ball and x gives the distance from where it escaped in feet. How far does the ball travel before it hits the ground? Well, you have to remember, when a baseball is hit, it does travel a parabolic path. Okay? Even if it's a line drive, it is somewhat of a parabola. A line drive is a parabola that kind of looks like that, a very small parabola. But a deep home run is very parabolic. Okay? So, how far does the ball travel before hitting the ground? How high does the ball go? And what is the reasonable domain of range for this function? So, we basically are going to use the graphing calculator to find the zeros of our function. So, our function is f of x, this is part A here, f of x equals -0.002x squared plus 0.77x. So we're going to graph that on our calculator, and we're going to find our zeros. So I'm going to put that in my calculator again. So -0.002x squared plus 0.77x. Now, I'm not even going to, when I first put that in my calculator, that looks like a blessed straight line. Okay, when I first put it in my calculator, it looks like this. That's because my calculator is way too zoomed in. I'm not seeing the full picture here. So what I need to do is zoom my calculator out. Okay, I need to be able to see it. So I'm going to go to on the TI-84, you're just going to hit zoom, and you're going to zoom out a couple of times. On the Inspire, you're going to hit the menu button, and you're going to go down to 4, which is window zoom. You're going to scroll over, and you want to zoom out. Okay? And it doesn't do much, so I'm going to zoom out again, and it doesn't do much again, and I'm going to zoom out another time. I'm going to hit that about 5 times, maybe more. And then you start to see, oh, look, it's a parabola. Okay, you get a lovely little parabolic screen. So now I can kind of find the zeros of it. Okay, so now I'm going to find the zeros just like I did before. So now I'm going to analyze graph, find my zeros, because you couldn't have found the zeros before. Find where my things go, and I'm going to hit enter, and go over here to find enter. I find one of my zeros is at 0, 0. Okay, one of my points where 0, 0 is one of my zeros. Okay, so x equals 0. My second 0, if I hit menu, analyze graph again, find my zeros. I find it's at 385 0. So basically, I now can figure out a few things. Right now I know that if it started here at 0, 0, and it ended here at 385, that means the ball traveled 385 feet. So A, the ball traveled 385 feet. Okay. Part B asks me, how high did my ball go? Well, now that I know it's 0, 0 is one starting point, and the ending point is 385, 0, and we know in the middle is the highest point, so what's half of 385? So we take 385 and divide it by 2, and you're going to get 192.5 feet. So the highest point of this ball was 192.5 feet. Right? No, sorry, excuse me. 192. You're going to get 192.5 feet. So y, we now need to solve for x. Okay? I'm going to say that it's not going to be 192.5 feet tall. That's the x value. This is my x value, is 192.5 feet. This is where my x is going to equal 192.5. I need to find how high it was when x was 192.5. To do that, we're going to find y when x equals 192.5. Okay? So you can do that in two ways. I can either put it into the original equation, the 0.002x squared, so I can put in 0.002 times 192.5, square that, okay, and then add 0.77x to get the answer. Or the second way of doing that exact same thing is to go back to my graph which I had before, okay, and I can use my equation that I had before. I can use that exact graph. Okay, x squared. I just deleted it off my calculator by mistake, so I got to put it back really fast. Okay, so then I could use a table to figure it out, or the easiest way to do it is go back to my analyzed graph, and instead of hitting 0 now, I want to hit a maximum. So if I hit maximum, and it's going to scroll me over there, so it's going to give me the same thing I did when I'm finding my zeros. So I'm going to try to figure out approximately what I think my maximum is, and then I'm going to do that, and it's going to tell me at 192.5, my height is 74.1 feet. Okay, so B is going to be 74.1 feet. So my ball is going to be 74.1 feet high at its halfway point. Right? Then what's a reasonable domain and range for this function? My domain, well, since I have to go to at least 385, I might say that my domain is going to be x has got to be greater than or equal to 0, but less than or equal to 400 would be reasonable. And for y, I have to go to at least 74.5, so maybe I'm going to say y has got to be greater than or equal to 0, but less than or equal to like 75. Or I can put 100, it doesn't really matter. Or I can put 80 or 90. Those answers can vary just a little bit as to what you want your domain and range to be. But this is solving quadratic equations.